Good day, everyone. Today we're going to start a new chapter concerning the parallel straight lines, which is chapter 20. Please open your grade 7 math books on page 187. Please look carefully and focus on the figure 1 in this slide. In figure 1, we can see the two straight lines D1 and D2 in the brown color cut by another green straight line delta, which is called in this case a secant. So the secant is a straight line that cuts the two brown straight lines in this case. We can see there is two intersection points A and B. A is the intersection point between the straight line D1 and the secant delta, while B is the intersection point between the straight line D2 and the secant delta. In this figure, we can notice an example of two corresponding angles marked in green. I mean these two small green circles drawn on the figure. Where in figure 2, please look at figure 2, we can notice another example of many corresponding angles. Each two corresponding angles are marked in a different color. For example, the relation between two blue angles, which are numbered by number 3 and number 5, is corresponding angles. We have another corresponding angles between the two red and the two orange and the two yellow angles in this figure. As we see, the two corresponding angles are located at the same side from the secant. For example, in figure 1, both of the two corresponding angles are located on the right from the secant. So finally, we can say that there is a relationship between any two angles. It's called corresponding angles. This relationship exists when two angles match the properties recently described. Now, what are the alternate interior angles? Looking at the figure 1, we can see an example of two alternate interior angles colored in red. We can draw in our imagination an inverted Z letter, which is in this case YBAX. The two alternate interior angles are located inside this imaginary Z. The two alternate interior angles are in this figure XAB and ABY. As we see, the two alternate interior angles are located at opposite sides from the secant, one on the right and one on the left. Figure number 2 allows us to see how these two alternate interior angles are located at the opposite sides from the secant. As I recently said, the angle XAB is located at the right side of the secant, colored in purple, while the other angle ABY is located at the left side of the secant, colored by yellow in this figure. So in a brief way, we can say that the alternate interior angles is a relationship between two angles situated at opposite sides of the secant that cuts two straight lines and form a Z letter. The two characteristics. So the characteristic number 2 is when two alternate interior angles is that they are located at the inside of these two straight lines, which are being cut by secant delta. They are located inside the two straight lines. And of course, thirdly, the third characteristic, they have different vertex. The first angle is with vertex A, while the second one has B as its vertex. In conclusion, we can say that there is a relationship between any two angles that matches the properties recently described. This relationship is called alternate interior angles. Going to the corresponding angles, as we see in this figure, the two corresponding angles are located at the same side from the secant, which is an opposite characteristic to the alternate interior angles. Also, we can see that one of the two angles in this figure is located at the interior side of the straight line, while the other corresponding angle is located at the external side of the other straight line. The third property is common with the alternate interior angles, that the corresponding angles have different vertex as well. A very important rule that we must know very well: when we have two angles, regardless the relationship between them, either they are corresponding angles or alternate interior angles, that exist with two parallel straight lines, so we can say that these two angles are equal. For example, as we see in figure 1, the two green straight lines x and y are parallel. So the two alternate interior angles located at A and B are equal, and they are equal to 55 degrees in this case. They are equal because they are firstly alternate interior angles, and secondly because the two straight lines are parallel. So two conditions. The first condition, that the two angles have a relationship between them, either alternate interior angles or corresponding angles, and the second condition is the two straight lines are parallel. In figure 2, the two corresponding angles are also equal, and in this case they are equal to 120 degrees. They are equal because firstly they are corresponding angles, as we said, and secondly because the two straight lines are parallel. The previous rule has a reciprocal property. That means we can think in the opposite way. So oppositely, if we have as given that the two corresponding or alternate interior angles are equal, as given, we can in this case assume that the two straight lines cut by a secant and forming these two angles are parallel. We can say in this case that these two straight lines are parallel. So either by given the two straight lines are parallel and we have to conclude that the two angles are equal, or by given the two angles are equal, so we can conclude that the two straight lines are parallel. Thank you for watching. I hope everything was clear in this presentation. See you and goodbye.